Okay, keep reading. Center of mass, very important topic है and बड़ा topic है. Center of mass that comes under system of particles only. And rotational motion is separate topic again. Okay. Center of mass means, what do you mean of center of mass? हाँ बोलो, सुनाओगे ना center of mass? The total mass of the body is assumed to be constant at one point. That point is called as center of mass. Okay. Even if you have so many particles also, center of the mass of the system of particles or the body is a point at which the entire mass of the system is assumed to be concentrated. The questions will be easy हो जाएगा. Okay. So suppose if you throw a baseball bat को अगर मैं throw करूंगा, एक एक पार्टिकल्स आर गोइंग इन डिफरेंट डिफरेंट ऑर्डर. एक पार्टिकल आगे जा रहे हैं, एक पार्टिकल पीछे आ रहे हैं, ऐसा पार्टिकल बहुत डिफिकल्ट होगा एक सिस्टम ऑफ पार्टिकल्स का. सो उसके वजह से दे फाउंड द सेंटर ऑफ मास. सी बेसबॉल बैट को अगर मैं थ्रो करूंगा, सेंटर ऑफ मास का मोशन इफ यू सी, इसका मास का सेंटर ऑफ मास ये नथिंग बट ए प्रोजेक्टाइल मोशन. नाउ इट इज इजी फॉर अस टू कैलकुलेट. इंस्टेड ऑफ ऑल द पार्टिकल्स we are seeing the center of mass, so then only we can study about the motion of that bat or something. Okay. And we already saw the importance of in potential energy में center of mass का concept बहुत use हुआ. Okay. Like we studied, right? Like this, when the rod of mass m is there, okay, and length l is there, is asking what is the gravitational potential energy. That time it is not mgh, right? We assume total mass is constant at one point and that length is l by 2. So answer is mg l by 2. We learned, right, this one. So I said center of mass बहुत काम आएगा. Okay. Sure. Okay. Now for center of mass of regular bodies ka, suppose if I take normal regular bodies ka, you know already center of mass will be at the center. देखो triangle का center, rectangle is there center में, and sphere is there, all are center only. Regular bodies ka center of mass is always at center only. But non-uniform bodies will be there, right? So in that way we want to calculate the center of mass. That all things we have to see. So center of, so many particles are there. Suppose m1, m2, m3, so many particles are there, which is at the distance r1, r2, r3. So center of mass is used by using the formula directly. We can calculate the center of mass. Center of mass means a coordinate we are seeing. That's it. Coordinate we are trying to find. So center of mass means something mass ka we are not finding. We are finding the coordinate of the center of mass. X coordinate kitna hoga, y coordinate kitna hoga, us system ka. Okay. By using the formula we can calculate. Okay. Sure. No. Center of mass of system of n discrete particles. Suppose मान लो you have n particles are there. See, x-axis, y-axis. M1 is there, which is at r1 distance. M2 is there, r2 distance. M3 is there, r3 distance. Like that, you have n number of particles are there. उस कंप्लीट सिस्टम का सेंटर ऑफ मास इज हाउ मच बोल के पूछेगा. मतलब जस्ट कोऑर्डिनेट्स फाइंड करने का. दैट्स इट. एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट एंड जेड कोऑर्डिनेट ऑफ द सेंटर ऑफ मास किधर लाई करेगा. दैट्स इट. ओके. सो सिस्टम का मास का फार्मूला है, देखो दिस इज अ फार्मूला. आर सी ओ एम इज इक्वल टू m1 r1 plus m2 r2 vector plus m3 r3 plus so on to mn rn by m1 plus m2 plus m3 so on to mn. So this is the center of mass ka formula. And when they given vector formula, use this formula. Okay. XCOM का formula m1 x1 plus m2 x2 plus m3 x3 so on to mn xn by m1 plus m2 x plus m3 ऐसा. Y coordinate z coordinate also formula is same. सो फॉर्मूला आ गया ना, m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. ये 3 particles आते हैं, that's why 3 particles. n particles है तो n particles यूज करने के. तो सेंटर ऑफ मास में समथिंग समथिंग नहीं है, दे विल गिव सिस्टम ऑफ पार्टिकल्स. आपको सिंपली पॉइंट्स कोऑर्डिनेट्स ऑफ ईच पार्टिकल का इफ यू नो वी कैन फाइंड सेंटर ऑफ मास इजीली इफ यू नो द कोऑर्डिनेट्स ऑफ ईच पार्टिकल का. ओके, फॉर्मूला आ गया ना, कुछ आ गया ना फॉर्मूला. XCOM का फॉर्मूला इज, टेल मी कृष्णा, XCOM का फॉर्मूला इज m1 x1
m1 x1 plus m2 x2 plus m3 x3 by m1 plus
m1 plus m2
m3.
plus m3. ओके चलो, नाउ इसका न्यूमेरिकल्स करेंगे. खत्म, वही फॉर्मूला सेंटर ऑफ मास का एक ही एक फॉर्मूला है, दैट्स इट. ओके, वी कैन फाइंड द कोऑर्डिनेट्स इफ आई नो द कोऑर्डिनेट्स x, y. If I know, I can find the center of mass of the system of particles. हाँ चल करो. 4 particles are there, which is 1 kg, 2 kg, 3 kg, 4 kg, are placed at the 4 vertices of A, B, C, D. Okay, here 1 kg is there. B is 2 kg, C is 3 kg, and D is 4 kg. Okay, and meter is 1 meter का distance है, all square है ना, all sides are equal. Find the position of center of mass of the particle. So आपको सेंटर ऑफ मास फाइंड करने के लिए एक पार्टिकल तो आपको ऑरिजिन मान रहे हैं इधर, एक पार्टिकल इज ऑरिजिन. नो, उसके रेस्पेक्ट में वी हैव टू कैलकुलेट द सेंटर ऑफ मास. ओके, नो यू नो ऑल द x कोऑर्डिनेट्स, ऑल द y कोऑर्डिनेट्स एंड सॉल्व करना है, दैट्स इट. सो XCOM का फॉर्मूला इज m1 x1 plus m2 x2 plus m3 x3.
1 by 2 I cap plus 3 by 5 j cap.
I cap जरूरत नहीं है, m2 plus m3 plus m4. हाँ, I cap जरूरत नहीं, जस्ट आंसर बोलो, कोऑर्डिनेट्स बोलो. कोऑर्डिनेट्स है
1 by
सेंटर.
2 comma 3 by 5.
हाँ, 1 by 2 comma 3 by
5.
no wrong. Y coordinate wrong.
So 3 by 5 only.
3 by 5. Yeah. Total mass
Sir, I
is
got
how much?
2 by 5.
Okay. m1 y1 plus m2 y2. ये भी 0 है ना? m3 y3 2 plus 4, right?
Plus 4, 6 by 10.
6 by 10 ना? 4 6 6 by 10 is 3 by 5. Yes, correct.
Sir,
आया?
won't be 4 by 10.
हाँ?
So won't it be 4 by 10?
हाँ, 4 by 10 कितना है?
2 by 5.
हाँ, नहीं, उसको आंसर डिफरेंट आ रहा है ना. m1 y1 0 plus m2 y2 0 plus m3 y3. So 2
Sir,
plus
M2
m4.
I2 is 3, right?
See, I'm taking this order. x1 y1 x2 y2 x3 y3 x2 y4 anything, any order. ऐसा नहीं कि यही x ऐसा मत ले लो, anything you can take. So कितना होगा? By m1 plus m2 plus m3 plus m4 is how much? 6 9 10. So it is 6 by 10 3 by 5. Okay.
Sir, but
Yeah,
isn't
all are
M2
addition.
moving in one direction?
Huh?
Won't M2, sir, you'll get 3 plus 1 by 10, right? Because M2 is moving up. So it'll be 3 into 1 and M1 is also moving up.
See, moving नहीं है. Who told moving? They told moving. This x-axis y-axis है. उसमें एक स्क्वायर है. Is not motion. अभी पूरा वाला रेस्ट है. Okay. उसमें I'm trying to find the center of mass का coordinate. मतलब indirectly what you got answer? 1 by 2 comma 3 by 5, right? मतलब origin से इधर है and y coordinate is 3 by 5. So इधर is the center of mass. This is center of mass का coordinates है 1 by 2 comma 3 by 5. मतलब इस सिस्टम का सेंटर ऑफ मास इज दिस मच. ओके, इज नॉट मूविंग टिल नाउ. मोशन ऑफ सेंटर ऑफ मास नॉट स्टार्टेड. ओके, चलो करो. नाउ एक एल शेप रॉड है. एल शेप रॉड है. टोटल मास ऑफ द एल शेप इज m. ओके, इसका लेंथ है l है, इसका भी लेंथ है l. नाउ इज आस्किंग व्हाट इज द And M is also attached at the end. Here one more M is there attached end. Asking what is the center of mass of the system.
So the length rod and the particle mass are same. Both the mass are same.
Yes, दोनों mass. Total mass is M. Total mass of the rod, L shape का rod is M. मतलब here three particles you can assume, right? So rod का we can take the help of center of mass. And this is origin, right? You can take this as origin. Origin से only we are calculating with respect to origin. No calculate कितना आएगा? In terms of L में आएगा. Solve करो. देखो L shape total rod is M, right? So I'm taking इस rod का uniform rod का center of mass is here M. I can write as M by 2. इस rod का mass is M, concentrated center. इस mass का rod is M by 2. And this is M. उसका coordinates आंसर आएगा कितना है?
Sir, 5 ml by 4 and ml by 4, comma
M
ml
क्यों?
by 4.
M नहीं रहेगा, नीचे कैंसिल हो जाएगा.
Oh, total mass. Sorry.
So इसका coordinates are y axis में x will be 0, 0 comma L by 2. And इसका coordinates क्या होगा?
0.
So L by 2 comma 0. And इसका coordinates are L comma 0. खत्म. Now use M1
5
x1.
L by 8 and L by 8.
Yes, correct. Now M1 x1 plus M2 x2 plus M3 x3 by M1 plus M2 plus M3. X coordinates आ जाएगा. Calculate. एक ही फॉर्मूला है, कुछ नहीं है, एक ही फॉर्मूला.
So you'll get the x coordinate as 5L by 8, right?
Yes, correct. Y coordinate में find करो.
ml by 8.
M किधर से?
L by 8.
हाँ, L by 8. समझ. So आपको XCOM का YCOM का अभी तक फॉर्मूला वी आर यूजिंग दैट सेम फॉर्मूला ओनली. आपको अगर कंटिन्यूअस बॉडी दिया तो वी आर एज्यूम दैट सेंटर ऑफ मास उधर लगा के कोऑर्डिनेट लगा के फाइंड करो कितना पार्टिकल्स है उतना पार्टिकल्स का लगाने का फॉर्मूला. दैट्स इट. ओके चलो तो करो जेई में क्वेश्चन देखते हैं. 3 points or masses are given. The sides also given.
0.9 centimeters and 2
You bad it,
centimeters.
करो.
Sir, I
नहीं.
did it yesterday only, sir.
No, करो.
Sir, that is the answer, sir.
Okay, no problem. देखेंगे. सिस्टम का सेंटर ऑफ मास चाहिए. So take one as origin and take the coordinates. Then it is easy for you. So 1 kg का reference ले लो, 1 kg का origin मान के ले लो always. If you know the coordinates only, then only you can
Sir, yeah,
substitute.
sir,
Right?
it's B. I got it.
Yes, B is answer. Print करो. Because you can assume this is x-axis, this is y-axis, so that you can find the coordinates easily. And 3 particles are there. One is origin, one is here, one is here.
Yes, sir, I got.
Yes. Okay. Next. So these three masses are placed in the equilateral triangle. Angle is 60. He is asking find the coordinates of the center of mass.
So do we need to convert the kg into grams? No need, right?
No need because cancel हो जाएगा नीचे में. Coordinates आ गया ना सबका? This is origin. This is 1,0. इसका coordinates में तो height चाहिए ना? x तो मालूम है 1/2 comma. हाँ y चाहिए. Y का you can use we know the sides, right? One equal triangle है ना? So you can use the Pythagoras theorem. Yes, C is answer.
1 second.
Yeah.
So won't the coordinates of M3 be 0.5, 0.5 by root 3?
0.5/3. ये height कैसा आएगा? देखो this is 0.5. This is 1. Pythagoras theorem. Use this formula. So under root 1 square minus 0.5 whole square. मतलब 1/4. So it is root 3/2. This is the height. So 1/2 comma root 3/2.
Yeah. Okay. Oh.
No substitute. M1 x1 plus M2 x2 plus M3 x3 by
Yeah,
M1
sir, if
plus
you
M2.
use that, sir, 150 into 0.5 only, right? For x coordinate.
150 into 0.5. Oh, no.
Yeah, sir,
75.
50 into 0 plus 100 into 0. Oh,
Ah.
100 to 1.
1 comma 0, right? X axis में y will be 0.
Yeah, sir, I got option C.
Yes. Pranav, getting answer. You know all coordinates, right? X1 find karo.
Yeah, sir, I got it.
How much you got?
Sir, I got x as 7/12 and y as 3/4.
Yes, correct. Okay. Next. 2 bodies 1 kg 3 kg have position vector is given in terms of vector form में दिया ना R1 यूज करने का. He's
Okay.
telling to find the center of mass system. Easy.
Sir, so M1 R. Oh no, man, nothing.
Sir, I got minus I by 2 plus minus I plus K by 2.
Minus I plus K by 2. No wrong.
Sir, I got minus 2 I cap minus J cap plus K cap.
Yes, correct. M1 R1 plus M2 R2 by M1 plus M2 करो neatly.
So you get minus 2I, no, like minus 2I minus J plus K, right?
Yes, correct. Hi, Krisha, आपको.
Sir, I'm getting minus 8 by 3 for I cap.
M1 R1. So I plus 2J plus K plus M2 R2. So minus 9I minus 6J plus 3K by M1 plus M2. So 4. So आपको J है. J is देखो minus 2 minus 6 minus plus 2 is how much? So minus 8I and minus 4J plus 4K by 4. So divide किया तो कितना आएगा? So minus 2I cap minus J cap plus K cap. है? Yes. So next. Now position of center of mass of two particle system. See, two particles का एक shortcut learn करेंगे. Okay. और एक shortcut use करेंगे for two particles का. Suppose मान लो you have these two particles of masses M1 M2. I want to find total length is L. I want to find the center of mass. Find करो center of mass. I am taking this as all. Here no coordinates, right? Whenever coordinates are not given, one is origin, and other point will be how much? Total distance is L, right? So it is x-axis में L, 0. Now find the distance from the origin. Center of mass find करो. R1 is how much?
M2 R2 by M1 plus M2.
M2 L by M1 plus M2.
M2 L by M1 plus M2.
Yeah.
Coordinates use करो. अच्छे से formula use करो. Since only x-axis में ही रहेगा center of mass, y-axis में नहीं लगेगा. So that's why again don't find y COM. Okay. X COM का formula M1 X1. So M1 X1 plus M2 X2 by M1 plus M2. So क्या आएगा? X COM मतलब R1 distance, right? X COM is nothing but distance from origin से center of mass, right? R1 is equal to M2 L by M1 plus M2. Can you tell me R2 कितना होगा अगर origin उधर लिया तो? R2 कितना है? मतलब
M1
distance
L by
कैसा आएगा?
M1
L by M1 plus M2. अब मतलब आपको ये फॉर्मूला बाहर करना पड़ेगा. Simply whenever R1 distance चाहिए from this M1 से चाहिए distance बोले तो M2 total length by M1 plus M2. Okay. अगर R2 distance चाहिए from इधर से R2 distance चाहिए center of mass का, तो क्या करेंगे? M1 total length by M1 plus M2. डायरेक्टली यूज करो, आ जाएगा. rather than coordinates यूज करके करने से अच्छा डायरेक्टली if I know the distance between the two particles ये शॉर्टकट जैसे यूज कर सकते हैं. Okay. So what is the formula? R1 is M2 L by M1 plus M2. R2 is M1 L by M1 plus M2. लर्न कर दिया? वो टू पार्टिकल्स का यूज करके सॉल्व करो अभी. And this relation always satisfy. M1 R1 is equal to M2 R2. देखो, if I multiply here M1 R1 means M1 multiply किया तो and इधर भी M2 multiply किया तो दोनों सेम है. So always the two particle system में m1 r1 is equal to m2 r2 always. It always true है. Okay, लिखो m1 r1 is equal to m2 r2. चलो एक नोट बोल के लिखो. सेंटर ऑफ मास लाइज बिटवीन टू पार्टिकल्स ऑफ द इक्वल मासेस, राइट. दिस वन तो मालूम है. टू इक्वल मासेस के बीच में सेंटर ऑफ मास ऑलवेज सेंटर में रहेगा. ओके. दूसरा, सेंटर ऑफ मास इज नियर टू द पार्टिकल हैविंग लार्जर मास. दोनों पार्टिकल्स आर देयर, वन इज 1 kg 2 kg. सेंटर ऑफ मास लाइज नियर टू द लार्जर मास का. सेंटर ऑफ मास का सेंटर में नहीं रहेगा, थोड़ा शिफ्ट हो जाएगा, राइट. एंड लास्ट वन में, center of mass of two particle systems lie on the line joining the center of mass of two particle systems. So center of mass always line joining the two masses के बीच में only somewhere lie करेगा. That's why XCOM में x axis में particles are there means XCOM में find करो. Don't find again YCOM. जीरो लगा के solve मत करो. So wherever the particles are there, उसी line joining में center of mass will be there. Okay, चलो नाउ करेंगे न्यूमेरिकल्स बेस्ड ऑन दिस. टू पार्टिकल्स का मासेस का कर देंगे. फॉर्मूला मालूम है ना, शॉर्टकट यूज करो ऑलवेज. हाँ. So particles 1 kg 2 kg is there. I want to find the position in दोनों का distance between them is 3. Find the position of center of mass. Find the position of center of mass. मतलब r1 मतलब ए origin से कितना दूर में है. That यूज करो इंस्टेड ऑफ कोऑर्डिनेट्स यूज करके. m1 x1 से अच्छा r1 फाइंड करो डिस्टेंस. टोटल लेंथ इज 3 meters, right? कितना अभी तक शॉर्टकट यूज करा, आंसर आ जाएगा. हाउ टू फाइंड r1? m2 l by m1 plus m2 यूज करो.
So
So
2.
हाँ,
R1 is 2. R2
r1
will
is
be 1.
या तो एक origin से we are trying to find distance. So instead of using, see formula से भी आएगा but shortcut यूज करो डायरेक्ट स्टेप्स में. टू masses में
So
m2.
for R2,
हाँ
So you get 2 and 1.
yeah,
two
sir,
and
won't
one.
R2 just be 3 minus R1?
नहीं अरे फॉर्मूला क्या था टेल में. r1 is from here see here r1 is how much? m2 l by m1 plus m2.
That's that I got, sir, for R2.
r2 क्या है? m1 l by m1 plus m2.
Yeah. So what is L? 1 into?
1 into length is how much? Total distance between them.
Oh, 3. Okay.
L is always we are doing the total length, right?
That's 2,
So 3
1.
by yes. So it is 2 and 1. Next. So इसका डिफाइन करो. Two particles of masses 4 kg 2 kg are located as shown in figure. Find out the position of center of mass. मैं कैलकुलेट देखते हैं. Distance between them is 5 meters.
So you'll get 1 second. So you'll get 10 by 3 and 5 by 3.
देखेंगे.
So I don't think that 37 degrees matter.
मतलब आपको कोऑर्डिनेट्स के लिए 37 डिग्रीज मैटर, राइट. देखो if we want the coordinates क्या आएगा, tell me how to find this 2 kg coordinates.
Draw
इसका
straight.
5 का cos 37 5 sin
Yeah,
37
yeah.
हाँ
So it's a 4, 3.
हाँ सो आंसर के देखूंगा किसका क्या है देखते हैं
Basically, we have to use it to find the coordinates.
without using coordinates also you can find with using coordinates you can find but दोनों चेक करो समझ में आएगा
Sir, I got 4/3 and 1.
आपको कृष्णा
So same thing, 4/3 and 1.
you also got same thing मानो
No, sir, I got 10/3 and 4/3.
डैड मत करो
Yes, I have to find the this thing only, right? The
फाइंड द
coordinate.
पोजीशन ऑफ सेंटर ऑफ मास किधर लाई करेगा बोल के
Yeah, I have to draw. I have to take component only.
नो कोऑर्डिनेट्स हाँ
Yeah, sir, I got 4/3, 1.
देखो 4/3 1 इज आंसर ओके सो m1 x1 plus m2 x2 x एक्सिस में दो अगर है तो यू कैन यूज द शॉर्टकट डायरेक्टली ओके x एक्सिस y एक्सिस में चलो now change in position of center of mass change in position of center of mass this is also very important exam में 100% आएगा whenever they keep the exam this type of concepts they will ask suppose मान लो आपके पास दो masses are there one is heavy mass one is lighter mass okay center of mass will lie near the heavy mass now question क्या है if I move the lighter mass towards the center of mass where will be the shift where the center of mass will shift that the type of questions are coming exam for my question two masses are there center of mass initially here hai I will move the position near to the center of mass particle ko ek particle ko I am moving near the center of mass definitely the position will change right that position kitna hai if I move 2 meters how much it will move ek type of question दूसरा type of question क्या है I will move the particle, but center of mass should not move. In that condition, में how much the other particle should move, either away or towards. ऐसा क्वेश्चन पूछेगा समझ में आया So in that में how to calculate the formula. Formula क्या है याद है किसका हो गया ना any formula whenever the how to find the change in position of
Then
the
you
center.
should take RCM as 0. And then
Okay,
equal the
formula?
whole thing to mx1 mr1 plus mr2 by m1 plus m2 is equal to 0.
थोड़ा चेंज देखो x COM का फॉर्मूला क्या था m1 x1 plus m2 x2 by m1 plus m2 two particles I'm taking I am partial differentiation I'm doing partial differentiation dx COM is equal to m1 dx1 मतलब dx1 is change in position plus m2 dx2 by m1 plus m2 ये फॉर्मूला बहुत इंपॉर्टेंट है एंड वी हैव टू यूज विथ साइन कन्वेंशन विथ साइन रखना पड़ेगा विथ साइन वेक्टर क्वांटिटी है ना वी हैव टू यूज राइट साइड पॉजिटिव ले लो लेफ्ट साइड नेगेटिव ले लो dx1 इज नथिंग बट चेंज इन पोजीशन आइदर राइट साइड में चेंज हुआ तो पॉजिटिव और लेफ्ट साइड चेंज हुआ तो नेगेटिव लगा सॉल्व करने का dx1 will be m1 dx1 plus m2 dx2 by m1 plus m2 whenever he says the center of mass is not changing at time dx is how much dx change in center of mass will be how much initial position and final position is same there is no change zero लगाने का then if center of mass is not changing then dx COM is 0 that means implies m1 dx1 plus m2 dx2 vectors is equal to 0 you can use this formula whenever center of mass is not changing m1 dx1 plus m2 dx2 is equal to 0 अगर change हुआ तो you can better to learn this formula एक formula learn करो खत्म ये formula use करो whenever the position is changing use this formula m1 dx1 plus m2 dx2 by m1 plus m2 okay समझ में आया चलो देखते हैं साइन कन्वेंशन के साथ, वो मिस्टेक हुआ तो रॉन्ग हो जाएगा आंसर। चलो क्या करो, two particles of masses 2 kg and 5 kg lie on the same line. Okay, 2 kg and 4 kg lying on the same line. Okay, if 4 kg is displaced rightwards by 5 meters, अगर इसको मैं 5 meters display करूंगा right side, then by what distance 2 kg should be moved, either this side or this side, we don't know, for which the center of mass remain in the same position. Center of mass before मान लो here है, the center of mass final also should be same. In that condition, we is trying to find the value of how much
So,
distance
so,
have
so
to.
they have to find
But
dx1 when they give dx2.
Yeah, find the x1. How much, Bruno?
It'll be 10 unit back.
उसको मतलब -10 है ना indirectly.
Yeah.
So since center of mass position is not changing, I can
Zero.
use that. So dx CY is 0. So I can use m1 dx1 plus m2 dx2
Yeah,
equal
so
to
you
0.
get dx1 as 10. Get
हाँ,
minus 10.
yes. So dx1 मान लो इधर. So m2 kg into dx1, right side positive, right? Plus 4 into 5 equal 0. So dx1 is equal to -10. मतलब indirectly, we can know that it is going, we have to move left side, move करना पड़ेगा. नहीं तो बहुत थिंक करना पड़ेगा, ये मूव कर रहे इधर, एक मूव एक इधर मूव कर रहे बोलते प्रॉब्लम हो जाएगा. बाय साइन कन्वेंशन यूज करके वी कैन गेट इजी, फाइनली वी हैव टू मूव लेफ्ट साइड बोल. ओके, नो करो. आई थिंक यू विल डू मिस्टेक. टेल आंसर.
Sir, 18 meters towards the left.
देखेंगे.
Yeah, sir. Same 18.
1 kg 2 kg lying on the same line. If that 2 kg is displaced
14,
10 meters towards right side, कितना?
14.
एक बोलो, 18 बोलता है 14 बोलता है.
Sir, I got 14.
Okay, देखेंगे. Right, then the distance of 1 kg should be moved so that the center of mass displaced by 2
Oh,
meters.
sir, 1 second. 6. Yeah, 14.
Left side or right side?
Left.
देखेंगे कृष्णा का भी
Sir, I
देखेंगे.
forgot to take m1 plus m2 in the denominator.
Yeah.
So even I'm
Krishna.
getting 40.
By left side or right side?
Say right side. Sorry,
By
left side.
right. Left side. Yeah. Right side नहीं तो left side बोलेगा.
No, sir, I forgot which one.
Okay. So negative में आएगा. आपको center of mass position is changing by 2 meters. This is important. That's why dx1 बोला. dx COM is nothing but here in this case में it is +2. खत्म. अगर लेफ्ट साइड है तो माइनस लगा के सॉल्व करने का. So that's why एक ही फॉर्मूला रन करेगा. dx COM is m1 dx1 plus m2 dx2 by m1 plus m2. Change in position of center of mass. So here we learned center of mass का formula. Suppose system of particles are given or point mass only. We are using till now not distributed mass. Continuous mass अभी तक start नहीं हुआ. The only point masses. That's why they call system of particles. So many particles are there. उसका center of mass find करो बोलते. We are using the formula m1 x1 plus m2 and change in position we learned. Okay. Shall. Now for a laminar 2D body for uniform negligible thickness. Laminar body is there suppose. So इसका formula क्या use करेगा? Laminar body means there is no thickness. एक plate है, very thin plate है. So उसका formula क्या use करेंगे center of mass का? Suppose they given 1 plate, 2 plate, 3 plate, and R1, R2, R3.
Shouldn't use sigma.
Okay. मतलब indirectly we are using the area wise we can use. Instead of M1, A1 आएगा. That's it. Simple. Center of mass का कैसा है देखो. देखो. Suppose you have plates है. A1, A2, A3, R1, R2, R3 distance are there, plates. So what is the formula we have to use? Simply this one. M1 A1 R1 plus A2 R2 plus A3 R3 by 1 plus M. Area A is the area. Whenever they're given in terms of area, we have to use area. That's it, simple. See, normally we have surface mass density will be there. Surface mass density is sigma. Sigma is equal to mass per unit area, right? So m के जगह में area into sigma किया तो पूरा sigma ऊपर नीचे cancel हो जाएगा. That's why we'll get here.
So, but for one of them will be sigma, for other will be minus sigma, right?
No, why minus sigma? All areas are given, right? All areas are given to you. So m1 a1 plus m2. नहीं माइनस वाला कब यूज करेगा मालूम है? Oh, that removal वाला. Okay. Suppose if I take one half of उसमें एक पार्ट निकाल दिया, कटिंग वाला में माइनस आएगा, बट ए वाला में प्लस. याद रखो. Till now we did not cut anything. m1 a1 r1 plus a2 r2 plus a3 r3 by a1 plus a2 plus a3. This is the formula we have to use for whenever they given uniform thickness.
Yeah, so done.
Okay, कृष्णा आपको. तो फॉर्मूला आ गया ना, m1 की जगह पे a1 यूज करेंगे. चलो क्या करो. Find the center of mass of a uniformly L-shaped lamina with dimensions as shown. The mass of the lamina is 3 kg. Total mass of the lamina is 3 kg. Now tell the answer. You find the center of mass. X coordinate, Y coordinate find करेंगे. If I find the area, no need of mass. No.
So can we like consider the two blocks as one system?
नहीं. आपको I told you whenever any uniform distributed mass is there, we have to assume total mass is concentrated at this place, right? And total mass is concentrated at this place. Okay. इसका coordinate क्या होगा? इसका coordinate, because आपको a1 x1 यूज करना पड़ेगा, right? x1 x2 coordinates मालूम पड़ने का. उसका coordinate क्या है? हाँ. So from this is origin, right? From this here से इधर तक 0.5 and इधर से इधर तक 1.5 या 1.5. करो.
Sir,
1
second. 2, 1.
So इसका कोऑर्डिनेट्स क्या होगा? इधर से इधर तक 1, इधर से इधर तक 1/2. और इसका कोऑर्डिनेट्स क्या है? इधर 1/2, 3/2.
How 1/2?
So this is 1, right? 1 plus 0.5, right?
Yeah, that even I got. So for the x coordinate.
X coordinate is how much?
How is it 1/2 is my question.
No.
No, sir, in the figure, like just now you wrote, right?
Figure में x this one
Yeah.
देखो
Yeah.
origin से कितना distance है ये वाला? This is how much?
Okay.
ये total 1 है ना? 1 का आधा.
Sir, 5/6 and 5/6.
Yes, very good, super.
Yeah, sir, same answer. If that
अभी तक coordinate you are asking me,
no,
got the same
no, sir,
answer.
after you do that, you'll get the coordinates.
Area we found, huh?
Wait, 1 second.
Find
Yeah, sir, area of the square is 1 and area of the rectangle is 2.
करो सब करो.
What is R
So
then?
why did they give mass?
See, if you want to convert into mass, any possibility is there? M1 x1 m2 x2 करने से अच्छा आपको प्लेट में कन्वर्ट कर रहा है. नोट ऑफ मास यूज जरूरत नहीं है. ओके.
Sir, what is R1 over here?
R1
Yeah, A1, I mean A1 X1, sorry.
XCOM is A1 X1. A1 X1
So if we take
plus
X1 as 1/2 or 1, it doesn't matter, right?
anything matter, anything same only. We are taking X1 X coordinate लेने का city कुछ भी ले लो because all are +1, right? So when you're taking this as A1 X1 मतलब उसका area 2 into 1
So 2
plus
plus 1/2 by
1/2
So 5 by
into
6, 5 by 6, yeah.
हमारे M1 plus M2 A1 plus A2 is कितना 2 plus 1 3, right? कितना 5/6, right? 5/6 5/6. So whenever laminar are given, simply take A1 X1 plus A2 X2. You understood,
so
right?
when
How
you
we
do
got
3/6, sir, not 5/6.
which one?
So when you do 2 plus 1/2 by 3.
2 plus 1/2 is 5/2, right? 5/2 by 3 is 5/6 only. Similarly, YCUM also we have to find A1 by 1 plus A2 by 2 by A1 plus A2.
Yeah, so done.
Yes. चलो ना करो. Now center of mass of a continuous mass distribution. अभी तक क्या है? Only point masses are there. Now we are talking about continuous mass distribution. हाँ. So इसका लिए फार्मूला क्या यूज करने वाला है? Continuous mass distribution का. Now some rigid bodies का भी लगा. Continuous mass distribution. Tell me what is the formula that you use for continuous mass distribution?
Sir, wasn't it sigma dm? Once again, not sigma, sorry, integration. Wait, I forgot. One second.
फॉर्मूला याद है प्रिशा आपको? आपको याद रहेगा ना? हाँ प्रणव tell.
So sigma into area of the hole. Oh wait, that's
No,
what
no.
I'm getting.
So what is the heading again?
Center of mass of continuous mass distribution.
Okay, yeah, done.
I want continuous mass distribution का how to find. मतलब I given suppose rod is there. Okay, uniform rod is there. Any shape का दिया.
Integrate,
So
sir.
So
इंटीग्रेट का
integration
फॉर्मूला
dm
क्या
by
है?
dm.
देखो I'll tell you. Position of the center of mass of a continuous mass distribution. Suppose मान लो you have x axis, y axis, z axis. एक continuous body is there. Okay, random
Sir,
body.
1 by m integration x dot dl.
Yes, correct. Okay, देखो you have continuous mass distribution is there. We have to find the center of mass from here. So कौन सा particle? It is made up of so many particles, right? A particle, A particle, A particle, A particle, so many particles are there. So हम लोग क्या करेंगे? एक small dm mass cut करेंगे. And इसका position is R. So what is the center of mass का formula क्या है? M1 X1, right? So M1 R1 plus M2 R2 plus M3 R3 ऐसा DM R1 plus DM R2 plus DM so on करने का. So उसके लिए वो addition of that उसको क्या बोलते हैं? Addition को we call as integration. So formula इसके लिए क्या use करेंगे? Simply integral x dm by integral dm. Okay. So what is making integration? Nothing but addition, right? And dm मिल गया तो capital M use करें. So integral x dm by m, integral y dm by integral dm, and integral z dm by integral dm.
So now this capital M is the sum of the masses, right?
Sum of the masses of the total body. They will give the given total mass of the body is m means we are substituting m.
So the x will be limits, right?
Limits will be there. They will be given based on the shape. You have to put the limits. Integral x dm by integral dm. Okay, continuous mass distribution का यूज करने का. सपोज मान ये भी याद रखो फॉर लीनियर मास ये भी लिख लो यूज होगा. लीनियर मास के लिए फॉर वन डायमेंशन व्हाट सिंबल वी यूज? लैम्डा. लैम्डा इज इक्वल टू dm by mass per small length. Okay, lambda is mass per unit length, right? Small dm by small dx. Similarly, surface mass density. Surface mass. When we are using for 2 dimension. 2 dimension में we are using sigma. Sigma is equal to mass per unit area. Mass per small, मतलब we are taking small mass per small area. And similarly for volume mass density, मतलब 3 dimension we have to use that one. So what is rho we have to use? Rho is small mass per unit volume. ये तीनों यूज करेंगे अगर कुछ है तो ओके. स्मॉल डीएम मास कट करने का वॉल्यूम में बोलते वी हैव टू यूज रो डीएम बाय डीवी. सो कंटिन्यूअस मास डिस्ट्रीब्यूशन का वी हैव टू यूज इंटीग्रेशन एक्स डीएम बाय डीएम. एक एग्जांपल ले लेंगे. सेंटर ऑफ मास ऑफ ए यूनिफॉर्म रॉड. ओके, एक रॉड है यूनिफॉर्म. आई प्लेस अलोंग द एक्स एक्सिस. देखो दिस एक्स एक्सिस, दिस वाई एक्सिस. I place a uniform rod of length L. Tell me, I want to calculate the center of mass of this rod. कितना होगा? Answer will be how much? Huh?
L by 2.
L by 2. Because uniformly distributed mass. But how we got L by 2? We'll calculate. Method समझेंगे. Then some variations को we can solve.
So can you go back for a second?
Yeah.
Yeah. Okay.
Got it? Yeah. Now, how to calculate L by 2 कैसा आएगा? Tell me. This is a uniform mass. देखो, if I take this as origin, इधर mass different distance है, इधर mass different distance है. It is made up of so many particles, right? So हम लोग क्या करेंगे? इधर से x distance दूर जाके एक small dm mass कट करेंगे. इसका dx length का उसका mass is dm mass कट करेंगे. I want to find the small, center of mass का we will calculate and then integrate किया तो we'll get that. What is the formula? What is the formula XCOM का? Because he is lying only on x-axis, that's why XCOM एक ही रहेगा. XCOM का formula क्या है? Integral. Tell me, what is the formula? Integral dm into x by under integral dm, right? ये है ना? Integral x dm by x is distance, right? Into dm by integral dm. Now dm, this is a linear mass density. आपको क्या यूज करेंगे? dm कितना होगा? मास कैसा आएगा? टोटल मास इज m मान लो एंड टोटल लेंथ इज l. सो l लेंथ में मास m है तो 1 यूनिट लेंथ में m by l and dx लेंथ में dm will be m by l times of dx. dx, right? This is a dm. This is nothing but dm. ना यूज करो. dm के जगह में लगाओ and x is x only, x distance दूर में only we cut, right? No solve. Integration from where to where we integrate? 0 to l and calculate and tell the answer. Integral integral dm will be all addition of masses and nothing but m only. So integral x dm के जगह में m by l dx by capital M. So mm cancel, 1 by l बाहर आ जाएगा. So 0 to l we have to integrate, right? So क्या आएगा? Integration of x ds is x square by 2. Limits are from 0 to l. So upper limit minus lower limit के तो l square by 2 minus 0. So l cancel. So l by 2 is answer. Method समझो कैसा क्या? Why we went for integration means एक एक पार्टिकल और एक एक डिस्टेंस है. dm different distance है. That's why we are taking the integration formula directly. And so dm we are calculating.
dx is dm.
This is nothing but dm, right? This because this mass है, पूरा mass है ना, mass only. एक इसका mass, small mass. Okay. So आपको ऐसा मेथड से करने का. अगर वेरिएशन दिया तो we have to solve this method में. Okay. चलो देखते हैं. हो गया? कवर. ये करो नो. A rod of length capital L is placed along the x-axis between 0 to L. Okay. x-axis, y-axis. एक रॉड है, सेम मेथड है. x equal 0 से लगाया. And length है L. He told lambda is a linear mass density, mass per unit length. And lambda they given as alpha times of x. Alpha is constant.
For the linear density again, In 1D, it was
mass
dm
per
by
unit
dx.
length.
dm by
dm by
dx.
dx. dm by dx. For small piece of piece का उसका. Okay. Find the position of center of mass of this rod. इधर इसमें अभी L/2 होगा. No, right? L/2 नहीं होगा. Why? Because here as the x increases, lambda is increasing. मतलब mass per unit length is increasing. ये कम मास है, ज्यादा मास है, ज्यादा मास है, ज्यादा मास, ज्यादा मास. So here non-uniform distribution है. This is non-uniform distribution. Non-uniform distribution. Now find center of mass का. So xc1 will be integral x dm by integral dm. Now find.
So 2L by 3.
Very good. Super. 12 by 3. Same way. इधर से x distance to जाके I'll cut a small dx length का element and उसका mass is dm. And lambda क्या है? Lambda is mass per unit length dm by dx. No solve. तो dm के जगह में आपको in terms of lambda में लिखेंगे then substitute करेंगे.
So
dm
the
is equal
denominator, you have to keep the limits as 0 and L, right?
0 to L.
Yeah, 1 second.
So,
Divided by.
because linear mass density means mass as the x is increasing, the mass is increasing. थोड़ा mass, ज़्यादा mass, ज़्यादा mass, ज़्यादा mass, बहुत ज़्यादा rod का. So that's why this is called non-uniform distribution. Lambda use करने का. X dm is lambda dx by integral lambda dx from 0 to L. Lambda constant आ जाएगा. No solve करो. And lambda के जगह में you can substitute. Okay, don't cancel. Lambda के जगह में substitute what is given, that's what substitute करो.
That's what I got it.
So x into lambda के जगह में alpha x, right? So x into alpha x dx.
So 2L by 3. Yeah.
2L by 3 आया आपको भी प्रणव?
Yes,
Integral
sir.
alpha x dx from 0 to L. So alpha बाहर आ जाएगा, cancel हो जाएगा. Then क्या होगा? x square. So ऊपर will be x cube by 3 from 0 to L by x dx is x square by 2 from 0 to L. So upper limit minus lower limit क्या था? So L cube by 3 by L square by 2. L square एक L कट करूँगा 2L by 3. So lambda can be, they can give 5x, 10x, 20x, 30x, anything. Answer will be actually 12 by 3 होगा सभी में. Why? Here alpha is getting cancelled, right? So आपको 3x से 3 cancel हो जाएगा, 5x से 5 cancel हो जाएगा. So 12 by 3 is a fixed one. आपको याद रख सकते हैं. If it is alpha times of x variable होगा तो 12 by 3 directly. Okay?
Yes.
चलो. now करो JEE में क्वेश्चन देखते हैं. I'll give options. Try.
So is that x by L whole square just for the B?
B into x by L whole square. That's it.
Okay.
So whenever this is nothing but rho is nothing but lambda only, indirect, right? Linear
Yeah.
mass density is symbol change कर दिया lambda. So always wherever dm is there, always use lambda dx. टू 2020 में आया जे मीन्स फॉर्मूला तो सेम है ना x c1 will be integral x dm by
2
integral
minutes,
dx.
sir. Almost done. Almost done.
या करो
Sir, over here the L cannot get integrated because it's constant, right?
l कितना l is constant
Okay, okay.
बाहर आ जाएगा ओनली x में रहेगा अंदर
So the first one.
देखेंगे
So I got 3/2
3/2 कौन सा
One
c या
second,
d
sir. One second. One second.
PD.
देखेंगे चेक करो दोनों का डिफरेंट डिफरेंट आंसर्स है ना चेक करो किसका रॉन्ग है किसका राइट है
First one only, sir.
ओके विल टेल फोर्थ वन ओनली सुनो
So let me recheck.
या चेक करो
Sir,
या टेल मी
why, sir, I'm getting 2a plus b by 3a plus b, but I'm getting 2l in the numerator. Like I'm not getting any fraction.
मतलब एलसीएम वगैरह लेने के बाद फ्रैक्शन मिलेगा बाजू में
L plus b, one second. BL, one second. BL square. L square. So BL cube by 3. So, sir, I'm getting 2. I'm getting 2L into 2a plus b by 3a plus b.
मतलब बाजू में फ्रैक्शन
I'm not getting a fraction, that's what. One
नहीं
second.
नहीं फ्रैक्शन आएगा आंसर इज फर्स्ट वन
Sir, if I did integration of x dm,
हाँ
I'll get L square into a by 2 plus b by 4.
इंटीग्रेशन न्यूमेटर क्या तो ax स्क्वायर बाई 2 आएगा.
Yeah, AL square by 2 plus BL power 4 by 4L square.
हाँ 4l स्क्वायर. ओके.
So I took L square common.
l स्क्वायर कॉमन लिया.
So you got A by 2 plus B by 4.
हाँ l स्क्वायर का निकल जाएगा ना.
Yeah.
हाँ नीचे यू विल गेट एज al स्क्वायर बाई 2. नहीं नहीं फर्स्ट एलसीएम लिया तो नॉर्मली. नीचे क्या आया था नीचे. इफ आई टेक कॉमन
नीचे I
ऑफ
got
al
नीचे I got AL plus BL by 3.
खत्म. ऊपर
Yeah.
यू गेट एज al स्क्वायर बाई 2 प्लस bl स्क्वायर बाई 4 बाई al प्लस bl बाई 3. नो l कॉमन ले लो, दोनों में से l कॉमन ले लो.
So I took L square. Yeah, I took L common. Yeah.
l ऊपर का l स्क्वायर नीचे l किया तो कैंसिल होके l बचेगा ना.
Yeah. So you get L into 4A plus 2B by 3A plus B.
l इंटू ठीक है एक मिनट. a बाई 2 प्लस b बाई 4 बाई a प्लस b बाई 3
Yeah,
टाइम्स
that
l.
into L. Yeah.
हाँ नो एलसीएम ले तो क्या आएगा इसमें.
4. Oh
So-
my God. Oh my.
हाँ तो ऊपर 3 बचेगा 4 बचेगा, बाहर 3 बाई 4 आएगा. 3 बाई 4 इंटू 2a प्लस b बाई 3a प्लस b इंटू l.
So but the answer should be 3 by 2. It can't be 3 by 4.
भाई 3 बाई
Be
4
3 by.
ये
Sir,
एलसीएम.
because sir, because if you get you'll get 3 by 4 into 4A plus 2B. But if you take so you'll get L into 4A plus 2B by 3A plus B into 3 by 4.
हाँ 3 बाई 4 आया ना.
Yeah, but that's 2L, right? It'll be L3 by 2.
अरे देखो इसके एलसीएम ले रहा हूँ 4. सो क्या आएगा 2a प्लस b बाई 4 बाई 3a प्लस b बाई 3 ओके इंटू l. सो ये ऊपर गया तो नीचे आए तो क्या होगा 3 बाई 4 आएगा. एंड जो सेम है वो दोनों सेम है टाइम्स l.
Oh, so I took the LCM only wrong.
हाँ टाइम्स ऑफ l दिस आंसर.
Yeah, so I got
Okay.
it. Yeah.
सो इसके बाद वी आर गोइंग फॉर द लाइक डिफरेंट शेप्स का. आई विल गिव द सेंटर ऑफ मासेस एंड देन कटिंग का भी है. कटिंग कैसा निकालने का उसका सेंटर ऑफ मास